Hi, welcome. So in this particular video, we'll be talking about implementation of queue using linked lists, right? So what is queue? As we understand, if you stand in the queue, maybe you are trying to buy a ticket from in the railway station itself. So you can see a like you can see a people standing in a particular queue. Now what exactly the concept is? The person who is in the front of the in the front of the counter will going to get the ticket first. And if anybody want to get the ticket, he has to move to the end of the queue, right? Yes. Same way, when you this the queue is simply like inserted at one end, which is called as the front, and deleted at the other end, which is called as the rear, right? And insertion operation is called as enqueue, and deletion operation is called as the dequeue, right? Okay. And since we are representing queue as a linked list, right, each of this particular will be a node. So I define this as struct node info struct node nets, and there will be two pointer, one which will pointing to the front, okay, where deletion will be happening, or the dequeue operation will be there, and one pointer will be pointing into the last element, okay, which will be called as the rear, right? Okay. And that where the insertion or enqueue will be happening, and there will be a function called as display, in order to display the queue itself, right? So same where I have mentioned as queue front, okay, the pointer, and queue rear, and initially I have put queue front and queue rear equal to null. Yes. Created manual, insert an element to the queue, okay, delete an element from the queue, uh display the queue, okay, then exit and enter the choice, okay, and then enqueue function, dequeue function, display, exit, okay. So this is the queue. So front will be representing the 13, okay, rear will be representing the 20 itself. So let us now write the code for enqueue itself. So void enqueue, okay, yes, great, enqueue, okay. Now the thing is, I want to insert into the queue. So what is the first thing that I need? I need one variable, okay, num, okay, and struct node star new node, yes, okay, and let me allocate the memory, new load, okay, struct struct node star, yes, because okay, malloc always return a void pointer, so I have typecast with the type of the pointer, which is nothing but struct node, right? Malloc. Now I have to give the what is the size, so I use the size of operator, and what is a string is my struct node, yes, right? Fine. So I will ask the user to give enter the number to be inserted, okay, fine, then semicolon scanf, or then percentage d, comma, ampersand now, yes, okay. Now the thing is that if the queue is empty, so queue front will be equal to null, okay. If queue front equal to null, that means queue is empty. So now what will happen is that, yes, so let me insert the element here. So new node, dash info equal to num, okay, insert element has been done. So I will write here queue front equal to queue rear, first element, right? Queue rear equal to new node, okay, and yes, so new node, okay, new node dash next equal to new another, okay, yes, right? So if front is null, that means nothing is there in this queue, okay. So queue front equal to queue rear, because the first element, so front will be also pointing to the first element, rear will be also pointing to the first element, and that is nothing but my new node. And new node next, it will be the null. So okay, the next one null, or else, right? Where I have to insert, I have to insert in the rear. So I have to write rear, okay, next, equal to new node, okay, and rear is equal to new node, okay, yes, and otherwise I can do one thing here. I can simply put this here, okay, so don't I have to put, okay, yes. So if front is red, it is a new element. Sorry, the queue is empty. So front is equal to rear equal to new node. Done. So I have already inserted now. I have put null value. Or else rear of next equal to new node and rear equal to new node. So my enqueue operation is done. Okay. So now let's do for the delete. Okay. So dequeue. Great. So again here. Okay. Let me take one pointer struct node star ptr. Okay. Now if queue front equal to null means printf. Okay. uh, Printf queue is empty. Yes, fine. Okay. Else if, now if it is only one node, that means queue front is equal to queue rear, only one element, only the first element. Then I will write like this. Okay. Printf the deleted element is percentage d, okay, to queue front info. Yes, right. Then I write ptr equal to queue front, okay, and queue front equal to queue rear equal to null, okay, because nothing is there now, and free ptr. Yes. So if I mention like this null, and what will happen to the element, first element, because I need to remove that, right? So I put a ptr pointer, ptr equal to queue front, and I remove this. Yes, otherwise this memory location I will never going to find out. So before I put queue front equal to queue equal to run, okay, I've assigned another pointer, and then after that I've freed that memory. Yes, else, okay, else I need to delete from where only, right? So simply I have to write here, copy, paste. Then the deleted element is queue rear info, right? And oh, sorry, deleted element is queue front itself, okay, and okay, ptr equal to queue front. Now front is equal to queue front next, sorry, yes, right. Now let me explain it to you. Let me bring this, then it will be clear. Okay, now rear is pointing to 20, sorry, delete, front is pointing to 13, okay, and rear is pointing to 20, okay. So that means I will simply display 13, q front equal to info means it will give you this 13. So ptr equal to q front, now ptr is pointing to 13, now q front equal to q front next, now q front will move to 12, okay, and ptr is pointing to 13, and free ptr means 13 will be removed. Done. And if it is like this, only one element 13 and null, that means front is equal to rear. Yes, right. So simply unite q front info means it will display 13, then ptr is pointing to 13, and q front equal to q rear equal to null, so complete and free ptr. Okay, and if free front equal to null, we know that it is empty. Okay, now void display. Okay, yes, so simple, I will copy this, right here. So first is if queue front equal to null, queue is empty, else I don't write if, else I will write ptr equal to queue front, yes, while ptr not equal to null. Okay, simply I write printf percentage d. I just need to display the element, okay, and comma. So let me do one thing. Sorry. Okay, it will be ptr info, ptr info. Yes, and next is ptr. Sorry, equal to ptr. Next, done. Okay, so let me save. Right, if queue front is null means queue is empty, then I took a pointer ptr and traverse till ptr is equal to null and I'm displaying it. That's all. Okay, let me execute. Okay, this is queue there, queue there. Okay, so let me execute free ptr semicolon execute. Okay, so this is my menu. So 2 means queue is empty, 3 means queue is empty. Okay, 1 insert. So I insert 12. So let me display. So I get 12. Okay, so let me insert now another element, that is 34. So it should be 12 and 34, right? Yes, 12 and 34. Okay, let me delete. So delete means 12, it will be gone. So deleted element is 12. Okay, let me display. It should display 34. So it is only displaying 34, right? Okay, so next again I put delete. So 34 element is deleted. Okay, display, it will be queue will be empty. Queue is empty. Again, if I want to delete, queue is empty, right? So this is working fine. Yes. Okay, so let me revisit again. Let me understand. Okay, so this is very clear structure, two pointer front and rear. Okay, just here is that if front is equal to null, then q front equal to q rear equal to new node, which I have entered. Okay, and if it is not like that, q of rear next equal to the new node and q rear equal to new node, right? I have answered at the end, right? And end is pointing by q rear, so q rear next will be into the new node. Now if I want to delete front if equal to null, then it is simply q is empty. Now if front equal to rear, that means only one element, so simply I have to write q front equal to q rear equal to null. Okay, and ptr equal to q front, so that I can easily remove this. Okay, and I have written the deleted element. Else simply the deleted element and q front is equal to q next, and ptr before that ptr equal to q front, so that I can free the memory and display. If q front equal to null, nothing. I take a pointer ptr and I traverse till it is null and I display. Yes. So I hope the queue is clear using, representing or implementing the queue using linked list. So if you are liking my video, please share with your friends and do subscribe it. Okay. Thank you so much.